We're going to start today on focus of parabola. We're going to actually spend today and tomorrow on this, so I'm hoping we get a good chunk done today. We're going to talk about the focus of a parabola. This is page 34 of your student journal, so if you don't have that out, go ahead and take it. Hey, you guys have your Chromebooks. We're talking about the focus of a parabola. Anyone know what a focus is? Cool. So we're going to talk about the focus today, and we're going to try one of these online explorations. All right? Because I think it does a good job at explaining this. Now you can, as you're going through this, it says work with a partner, but it says go to Big Ideas for an interactive tool. That's what we're going to use. Okay? So you can take your notes on here. It'll ask the same question. You draw the pictures and all that cool stuff. All right? So what you need to do, and I'm going to, let me switch this over so you can actually see it. I need you to go to bigideas.com or the Clever website, right? You get in here. So you go to Clever, you go to here. We're good? Raise your hand if you're there. Raise your hand if you're not there. Okay, you guys almost there? You getting close? All right, it's loading. Hopefully it doesn't load forever, because sometimes when these load forever, that means we're going to have issues that day. So you guys are the first ones I am trying an online exploration with. Do you feel like pumped? Yeah. I was nervous like all weekend. I was like, should I? Shouldn't I? Should I? Shouldn't I? Yeah, using a daisy. Okay, so I want you to go ahead and hit Student Dynamic eBook once you're in here. It should bring you to that page. Not as quick as mine, because I already loaded mine, because mine takes forever to load, so I figured I'd load early. Yeah, it'll open the last page you're on. And once you're there, go to Table of Contents and go to Chapter 2 and 2.3. 2.3. Okay, page 67 for those of you who want the page number. And you'll see something that looks really close, well, almost identical to your student journal page. How many are there? Oh, that's actually quicker than I thought for some reason. It's like cat-like speed. Okay, how many are there now? How many are still waiting for it to load? Come on. You're stuck in the wheel of infinity. Here's what I want you to do. On this page, you need to find this little amazing 5-dot thingy. Right here. And you click on it. And it's going to bring you to this thing called GeoGebra. And from there, you are going to follow the instructions. Now, I should have loaded this. See, this is how quickly mine loads. Well, actually, it's doing pretty fast.
Oh, it's there. Yes.
Okay, you click on it, and it allows you, once you click on it, it'll give you some options here. So, what I'd like you to do is mess around with this. Follow this, read the directions, mess around with it, and figure out what a focus is, please. Off you go. So, hey, we're supposed to be able to draw the reflected ray. Okay. Well, first, raise the vertical rays, enter a satellite dish, like so. Ray 1, ray 2, and ray 3. Okay. They hit the parabola and then they reflect to a single angle, or reflect at the same angle they entered. Okay, you can click on and drag on this orange little diamond. So notice when I do that, the angle that came would be congruent to that angle. And this one, as it comes in here, draw it out. Now notice, all of those rays that come out hit at a single point. That point is called your focus. Okay? That is your focus. How many were able to find that? And note, when you adjust the parabola, it doesn't matter. The focus moves with it. Okay? As those angles go. All right, so what I want you to do is, looking back at your student journal now, I want you to summarize that information on your student journal for your notes, please. Okay? You may talk about it with your groupie, summarize that. So I've drawn in my reflected rays. Okay, all of these intersect at 0, 1. All rays that enter the satellite dish, intersect at point 0, 1. That is our focus here. Okay? So somehow highlighting and explaining that where those rays intersect is called your focus. All right. So some practical applications, stuff that you use all the time. Hey, if you turn, go ahead and take a look at your next page in your student journal, page 35. Okay? So, exploration number 2 talks about analyzing spotlights, or think of maybe a flashlight. Okay? That shape inside the flashlight, and I'm not talking about your little phone where you're like, haha, my help a light or whatever it is. Okay? You're like an actual flashlight. Okay? All right. So what I want you to do, go ahead and go back to your go ahead and close that tab. Go back to your online textbook here and go to Exploration 2. Click this one down here this time. All right, you're going to do exploration number 2 using GeoGebra. You know what? We don't like segregate our maths here. We're all about equal opportunity math. Okay? We give geometry and algebra the same amount of time, at least today. Okay? Then we'll go back to algebra. All right? So there we go. Okay, so taking a look at this one. Beams of light are coming from the bulb of a satellite. And this time, we're dragging here. And notice the beams coming from the bulb, they hit. Let's see if I can scroll down here. They hit the parabola, and then they go out at that same angle that they came in. What happens with the beams? Matt, they are parallel lines. Okay? So the light, the bulb, hits the outside of the parabola and reflects the light outward. So it's giving you a focused beam of light. All your light rays are going outward in parallel lines. Okay? That is the benefit of having your focus there. And we put a parabolic shape around those light bulbs in a flashlight to make it so that you have a focused beam of light. Now, if you think of your phone, when you shine your phone, it's like ultra bright, but sometimes it doesn't give you as good of a visual as like a flashlight would that doesn't seem as bright, because those rays are focused, whereas your phone may not be. Okay, any questions there? All right, did everyone summarize that page? Okay, your exploration. If you go back to that, so on this page here, hopefully you're able to summarize it up. Okay, this is page 35. A point on the inside of the parabola that lies on the axis of symmetry is your focus. Okay, describe some of the properties of the focus. Well, you can do that later, but hopefully at least summarize this piece up here. Okay? Okay. All right, I want you to take a minute and just talk to your neighbors about what you learned there. Kind of get it straight in your head, because we're going to add some other terms that you've never heard before here in a minute. Guys, sorry about my messy writing. Okay, that's me working on it at home really fast. But since all beams leave the parabola parallel, they'll all be pointing at the same object. Okay? All right. Hey, I want you to take a look at your student journal just real quick. Page 36. There's some other terms here, but I want to make sure that there was a mistake I saw earlier on. I want to make sure it's not. I haven't looked at your journals, but down here on page 36, we know what focus is, and we'll talk about Directrix here in a minute, but if you look down here at your horizontal, does it say Y for everyone or X? Okay, it should read X is equal to 1 over 4 PY squared, so please change that to an X. Okay? Otherwise, it's incorrect. On mine, it says X, but I just printed this off of the website, so yeah, it should say X equals. Okay? All right. That top one should say Y. Everything else should be accurate, but I believe this should be X. Okay? All right, so let's talk about some other definitions. This is in your textbook, page 68. You don't have to turn there if you want to. I guess you could look on your computer there. But this right here says exploring the focus and the directrix. Now we've talked about what the focus is. Okay, the focus is the interior of the parabola and lies on the axis of symmetry. It's equidistant away from the edge of the parabola. Okay, if you hit that parabola and then go downward, the directrix is perpendicular to the axis of symmetry, and it's the same distance away as the focus is. What you need to know, and here's the easiest way I think about this. If we call this, say, give me a value here that I can make this. 5. Okay, I like 5 right now. Okay, 5, that is 5 on the y-axis. I'm just making up a number. If that's 5, okay, this distance right here, let's say this is my origin. If that was 0, 0, this distance is the same as this. So it would make this what? Make it -5. Okay, this is a coordinate. This would be the ordered pair 0, 5. That would be that point. This is an equation. This would be the equation y equals -5. The directrix is a reflection of where the focus is, of the line the focus lies on, upon the vertex. It's the same distance away. Okay? The vertex always is halfway between the focus and the directrix. So, for those of you that really want to take and copy down something that I think will help you with this, this is page 68 of your book. I'm not going to give you time to copy that whole thing, but it's in your textbook. It's page 68, or you can look online. Or you can come back, I'm recording this, you come back and look at it here. Okay? All right. Now, what I think is extremely confusing, if you're brand new to this, is this page. This is your note page. Okay, actually, that's the second part of it. This is the first part of your note page. This is page 35, 36 of your student journal. The vertical axis of symmetry, x equals 0. Okay, so we know this axis of symmetry. They're saying the equation of this is y equals 1/4 p over x squared. The only reason they're putting this is they're saying if you want to find out if you want to know the focus, this is an equation you can use. Okay? The focus we're going to call the ordered pair 0p. If our vertex, if our axis of symmetry is the y-axis. The directrix then would be the reflection of that. Okay, so I think this is mass confusing if you don't know any of this yet. Okay, I also think that the next page, page 37, take a look at that. I also think that mathese right there is mass confusing if you don't understand this yet. So what I want to do is I actually want to try some of these, and then you can come back and scribble all kinds of notes on this that make sense to you. All right? Or you can never look at this again and just use your note page. That'll be up to you. All right, so here's what I want to do. Let's try some problems from the monitoring progress. Let's take a look at number 1 here. This is out of your textbook. This is the monitoring progress. Okay? Just looking at that, it says use the distance formula, and I'm opposed to using it because I think it wastes your time right now. Okay? So I'm going to just say, I'm going to get rid of that part. And I'm just going to say, write an equation of the parabola with a focus at 0, -3, okay, and a directrix at y equals 3. So here's a picture of what they're saying. Here's my parabola, here's my focus, here's my directrix. Okay, now you're looking at this and hopefully you could tell me something about my A term. My A term would have to be what? Negative. It's opening downward. I do not expect you to look at that and go, oh yeah, that's easy. It's just this. Because it's not easy if you've never done this. But what we want to do is we know that this is P. Okay? Our focus is always the ordered pair whatever for x and P for y. So if you know the value of your focus, your y value is P. That's something to put in your notes. Like if I can tell you the coordinates of my focus, you automatically know what P is. And how is that helpful? Well, there's an equation. If you're dealing with a standard parabola that opens up or down, your equation to write your equation, you use 1 over 4p equals x squared. Or excuse me, 1 over 4p times x squared equals y. Well, what does that mean? Well, it means, like in this case, y equals 1 over 4 times what? -3. Now let me pause there for a minute. Kendall? Are you looking at that note page? Don't look at that note page right now. Okay? I'll explain that here in a minute, but don't look at that yet. Okay, just let's focus on this. I didn't even do that on purpose, but good job, Zach. Well done. All right, so we get y equals -1/12 x squared. And remember that negative can go anywhere. It just so happens it's at the 12. And we know it should be negative. This is our a term. That is the equation. Okay, so that's all brand new, I'm assuming, to everyone. Is that true? Anyone already know about this before today? I just did a little studying on your own. Okay. All right. From this picture, you should be able to find the coordinates of the vertex. The y value is p. You plug p into this equation. Will this equation always be the same? That's where Kendall's question comes in. Okay? This equation is the same when you have a vertical axis of symmetry. So Kendall, your question, what's it mean by horizontal vertical axis of symmetry? Well, here's your axis of symmetry. In this case, it happens to be the y-axis. That means my parabola is not shifted left or right. Right? It's a normal parabola. It's opening downward. It has a vertical axis of symmetry on the y-axis. So this is the equation we use. We good? Okay. Dallas, your hand up?
Yeah.
What's up?
When the fraction 1/4, is it
Always
always 1/4?
1/4 p. Yep. Yep, that's not going to change on you. Yeah.
If that's what a vertical axis symmetry looks like, what does the horizontal look like?
That's a good question. What's the horizontal look like? Well, the horizontal, notice, that kind of let us in. This is back to your note page now in your student journal. So you have a little background now, maybe where you can add some notes that this will make sense. We can use this equation. If it's a quadratic, our focus always has this coordinate. Our y value is always p. The directrix is always the opposite of p. And our vertical axis of symmetry goes like this, meaning our parabola opens upward or downward. If we have a horizontal axis of symmetry, the only thing that changes now, our parabola opens sideways. That means it's not a function anymore, right? Is that what you're going to say, Zach? Yeah, the equation, the only thing that changes, notice x's and y's and switch, right? Everything that was x becomes y. And our p is no longer with the y value, it's with the x value. It's still 1/4 though.
Does that have a separate function name? Is that like exponential?
Well, actually, you would deal with square root functions later, but that's hard to relate it to that right now. Okay. All right. How many are with me? Brand new stuff. Walsh, you with me?
Yeah.
You sure?
I mean, like, it's a little confusing, but confusing in the way that I just don't know it all yet, and I'm sure.
Okay, well, let's try these. These will hopefully confuse us less. Identify the focus, directrix, and axis of symmetry of the parabola. We're not going to worry about graphing it quite yet. Okay? All right. Focus, directrix, and axis of symmetry of the parabola. Okay, we know if y equals 1 over 4p, I know you're not done with all these, but let's look at the first one, x squared. Notice this part right here is the same, and this part is the same, so that means 1 over 4p equals 1 over 4p equals 0.5. Another way of thinking of 0.5 is 1/2. Okay, did I lose anyone right there? This equals that. Now, you'll notice that the ones are the same, which really means 4p equals 2. So what's p? It's 1/2. So if we're identifying the focus, we know that this parabola opens which way? It looks like this, so a quick picture might help. Okay, which also mean, or we also know that it doesn't have any shifts because there's no h term in there. So this has a focus of the ordered pair 0, 1/2. That's our focus. If it hasn't shifted up or down, or left or right, that means the vertex is at the origin. Which means if we go 1/2 up to get to the focus, how far do we go down to get to the directrix? 1/2. So the directrix is y equals negative 1/2. Emily?
So if that graph would have been shifted like over 1 and up 1, how would that affect the focus?
It's a good question. If the graph was shifted over 1 and up 1, how would that shift the focus? Can we get to that as we progress? Okay, it's going to move it for sure, and it's going to change. So it'll change this, but it'll change this because we're going up 1 as well. So it's going to move this to the right, and it's going to move it up. But let's kind of stay here for now. Okay, it's good. I'm glad that you're thinking that. Axis of symmetry. What is the axis of symmetry? X equals 0. Right. It's your x value. This is your axis of symmetry. This value here, and this will always give you the opposite this. Will give you your directrix. This is always the opposite of your directrix. Okay. So when you're looking at this one, what's wrong with this one right away? It's negative y. So let's make it positive y, which is going to make this negative x squared. Okay, so once again, if you think of it as y equals 1 over 4p, x squared, these pieces are the same. This is a negative 1, so we have 1 over 4p equals negative 1. Or if you want to, you could think of it as positive 1 over negative 1. Right? If that's confusing to you, just think of it as 1 over 4p equals negative 1. How do you solve that? Cross multiply and divide. It gives you negative 4p equals 1. Or 4p equals negative 1, however you want to think of that. So p is negative 1/4, which means my focus is at 0, negative 1/4. We haven't shifted this left or right, right? We haven't shifted it up or down, so it's still at the vertex. The vertex is at the origin. My directrix, this graph, by the way, opens downward, right? Okay, we know that because it's a negative. My directrix then is opposite this, so it's y equals 1/4, and the axis of symmetry is
0.
x equals 0. So it doesn't look like a 5. Yeah, it's pretty awesome. All right, how many are with me? Which way is this parabola opening? It's a y squared. That opens sideways, yeah. So if I think of it this way, to get rid of this 6, that's going to be, you know, how about we pick up there tomorrow? Okay, hey, hold on. Before you go today, take a look at your student journal, page 37. Page 37. I want you to do problems 1 and 2. Use the distance formula. Okay, oops, keep the right in equation. Write the equation of a parabola. Okay, number 1 and 2, and then take a look at the next page. Okay. I want you to complete number 6, 7, and 8. 1, 2, 6, 7, and 8. Okay? All right. Very good. Good job today. Stay with it. Student Journal 1, 2, 6, 7, and 8 today.